Hi, continuing with section 11.8, we are looking at power series now, and we are trying to find out which, for which values of x the series converge. Remember, this is the difference between the power series and just the series, that we have now x in here. So let's look at the next example. In the first, we saw that we have to check we can get an interval by using our ratio test for the series, but then we have to check the endpoints. And in the first example, both endpoints were included in the interval. Let's look at this next one. So this is n factorial 2x plus 1 raised to power n. So I will do it the same way. An is n factorial 2x plus 1 to the n. So an plus 1 will be equal to n plus 1 factorial 2x plus 1 whole to the n plus 1. So I will apply the ratio test. So I say L equals limit as n goes to infinity of a n plus 1 over a n absolute, which means is equal to limit n goes to infinity absolute value of n plus 1 factorial times 2x plus 1 raised to n plus 1, all thing divided by n factorial into 2x plus 1 raised to the power n. You can see that it simplifies to so we can split the bigger factorial, which is the n plus 1. You can write it as n plus 1 times n factorial, and then at the bottom I have n factorial, but from the expression of x, 2x plus 1, on the top I have power n plus 1, at the bottom I have power just n, so I'm left with only 1 2x plus 1 factor in the top. So now n factorial and n factorial get cancelled, and we basically we can pull out the term with n. So n goes to infinity, and we have n plus 1 and times absolute value of 2x plus 1. Now, since we, the term that we set less than 0 is always going to be the one in which the limit has been evaluated. So I cannot say from here that the series will converge when this thing is less than 1. I have to first apply the limit. But when I apply the limit, it becomes infinity. So what does that mean? It means no matter what x value of x you have, the limit is not going to exist, or limit is going to be infinity, which is a number bigger than 1. So it means it will diverge. So diverges. Now we have to check. So there is no endpoint we have to check, but it will converge. Remember, as power series will converge. There will be at least one point where it converges. So what will be the interval of convergence? So we have to now check what is x minus a. So what is our a? How do you find it? Well, you can take this expression of x and set it equal to 0, or you can factor this 2 out and figure out. Actually, you will need the negative sign as a. So we want it to be x minus a. So diverges but converges at, so at what point? We go on a side, 2x plus 1 equal to 0 gives me 2x is equal to negative 1. So x is equal to negative 1 half. So we say converges at x is equal to negative 1 half. So in this case, what is this case? This is the case, if you recall from before. It is this situation where it is converging at only one point, so radius will be 0. Going back, so I say interval of convergence. Although it's not an interval, but just one point, single point, and the radius or r, so that's how you write it. Yeah, I hope you got this one. Let's look at the next one. Okay, let me change the color. I just got bored of the same color. Okay, so x minus 6 raised to the power n divided by n raised to the power n. Okay, so we have a sub n. Now this, you if you go, I think it's section 11.4 or 5, I think, that has root test and ratio test and root test. We didn't cover the root test. If you know the root test, you can apply that on this example, and that makes things simpler. But ratio test also works. I'm going to show you with the ratio test. So an here is x minus 6 to the n whole divided by n to the n. So an plus 1 will be x minus 6 raised to n plus 1 whole divided by n plus 1 raised to n plus 1. So again, remember these are fractions. So we have to find the ratio an plus 1 over an. Now I'm showing you this problem or solution of the problem in slightly different form. I'm not putting the LIM outside. I just start with this one. So simplify it, and then we can introduce the limit at the end. So I get a will be x minus a to the a is n plus 1, the n plus 1th term. So x minus 6 raised to n plus 1 over n plus 1 raised to n plus 1. Okay. So which divided by a sub n, which means multiplied by the reciprocal of a sub n, which will be n to the n over x minus 6 raised to n, which is, and the absolute values. Okay. Which is going to give us, notice here the n's won't cancel at this moment, but these terms, these do not cancel at this moment. So what we do, we see the this x minus 6 to the n plus 1 over x minus 6 to the n gives us x minus 6 term. Just one factor. So I have x minus 6, and then I can write the other one as, so I keep this one as n to the n, but the bottom one can be split as n plus 1 to the n times n plus 1. Now again, this is exponent rules. I hope you guys know these because it's very important to know the exponent rules in this section, in this chapter basically. To know what? So it can be written as absolute value of x minus 6. Okay, I can keep the things in there. So over n plus 1 times, now I have the n to the n over n plus 1 to the n. So I can write it as n over n plus 1 whole raised to n. Again, because of the rules, exponent rules. Okay, so now at this point, we can apply the limit, or you can go one more step. How do you simplify this? When you have to apply limit, you basically will divide by n each term, and you will end up getting 1 over 1 plus 1 over n. Or you can think of it this way, because when you apply limit, this is what is going to happen. You can also think of it this way. So that's limit L equals limit as n goes to infinity of this quantity so it will be applied on the n plus 1 at the bottom here, and it will be applied to this quantity. So I'm going to write it like limit n goes to infinity of 1 over n plus 1 times limit n over n plus 1 raised to the power n times the absolute value of x minus x. But now notice here, this limit goes to 1, this limit goes to 1. So we are getting 1 raised to the power infinity, which is 1. And then we have this limit. So the other one, this goes to 0. So no matter what we have here, this everything will give us 0. What does that mean? That means the series will converge no matter what. No matter what the value of x is, this is always going to converge. So this says no matter what x is, the series is always going to converge. So you saw two, okay, therefore, what do we say? Therefore, interval of convergence equal to negative infinity to infinity, and radius or r is equal to infinity. So you saw example where we have the whole real number line is the interval of convergence, and r will be infinity in that case. And then we saw another example, previous one, in which only one single point was the interval of convergence and r was 0 there. Before that, the first example, we saw that there is a particular interval of convergence, and we saw that both endpoints were included in the interval. I have one more example, but I will stop the video now and let you guys try doing this one. and then I'll come back in the third video to show you the solution.